following movie will create a thermal fatigue analysis of a bracket that supports an electronic box. We'll take a look at how the cyclic thermal load and an offset load of a G load affects the life of the bracket. So we'll begin by cloning an existing solution, linear static one, that has the temperatures and G load in it, and we'll change the G load that was existing. It initially was a shock G load at 10 Gs to a 1 G load, and we'll create an additional subcase that will be the 1 G load plus the temperatures. So here's our 1 G load. We'll put that into the 1 G load plus the temperature subcase, and then we'll take the temperatures from the temperature subcase and add that to the 1 G load plus temperature subcase. All right, now that we have that, we'll go ahead and make sure that we're requesting strain output, because we'll need the strain for the life prediction from the durability analysis. All right, now we're ready to go ahead and run that linear static simulation that will be the foundation for our durability solution. I'll go ahead and pause the movie while it runs. You can see it's about 18 seconds to solve the linear static run. And here we can take a quick look at those results, and you can see we've got 3 subcases worth of results. Here's our temperature subcase, our G load subcase, and then our combined subcase. All right, so that looks good. Now we'll create our thermal fatigue durability solution. And we'll create a new static event from the linear static solution that we just created with a result path type excitation. We'll begin by setting some of the options for the durability analysis to request margin of safety results, as well as the stress criterion that we'd like to use. Here we'd also like failure index results. I'll keep the number of occurrences at 1 so we can get a true life cycles to failure. Here we can select the element face stress axis that we'd like to use. And for our solve options, since we're only interested in the life of the bracket, we'll just select those elements for the bracket for the results. All right, now we'll go ahead and define our excitation. And that result path is going to have 3 points. It's going to start and end with a G load, and it's going to have the 1 G load plus the temperatures in between. So that way we have a static offset of the G load. Here's a sort of a visual XY plot of what that result path is going to look like for our excitation. All right, and then we're ready to go ahead and solve. We can turn on the checks to see if everything is okay with the setup, which you can see that it is. And then we can go ahead and take a look at our results. Here we can get our fatigue life results. You can see our cycles to failure are over 10 to the 11th, so that looks good. And here we can also take a look at our fatigue failure index results. And that concludes the demonstration.